Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 3, Notes 3. Today we're talking about multiplying monomials. We'll talk about that word monomial. So our learning target today is I can multiply monomials. Now, we've been talking about polynomials for the last 2 days. So what in the world is a monomial? A monomial is a number, variable, or product of a number and one or more variables. Monomials that are real numbers are just called constants. So basically, think of the word mono. Mono is a prefix that means one. Okay, this means one. So what a monomial is one term. Okay, that's what that means. When we were talking about polynomials, the prefix poly means many. So that was something that had many terms. Okay, so a monomial is just one terms. So now we're getting into multiplying monomials, meaning we have no addition or subtraction here, because addition and subtraction is what we use to separate terms. But if we're looking at a monomial, they all have one term. So there's a couple of rules that we need to talk about and what happens when we multiply monomials. So the first one, when we are using the product of powers rule, meaning we're multiplying powers, we are adding their exponents. So multiplying powers, when we multiply powers, we add their exponent. Okay, so for example, if I had something like a to the sixth times a to the third, I add 6 plus 3. This multiplication is implied, by the way, even though it's not there, just like it was before. A to the sixth times a to the third, 6 plus 3 gives me 9. That's a to the ninth. Okay, um, the power of a power. Okay, when we have a power of a power, we are going to multiply their exponents. So it's kind of like I'm doing the operation underneath it. When I was multiplying powers, I'm going to add just the exponents. Okay, notice by the way that the base didn't change. The base does not change. Okay, so then when I have power of a power, I multiply their exponents. So when I have something like this, 6a to the sixth squared, this is a power inside that's being raised to a power outside. When you see power of a power, you're almost always going to see parentheses. So it's kind of like having a power outside of a power that's inside the parentheses. So what happens here is I need to take 6 squared, which is 36, and then I need a to the sixth squared, which I do 6 times 2, and that's a to the 12th. So the number part was raised to the power, like normal. We're used to that. 6 squared is 36. But the variable part, I multiplied the exponents. So I do the operation underneath it with the powers, with the exponents. And then the other power that we're going to talk about today, this is a pretty simple one. Anything that's raised to the 0 power is equal to 1. So I could have something that looks entirely like this. 10,000 times a to the third. It's all being raised to the 0 power. This whole thing is just equal to 1. Okay. So let's do let's write out some steps here of how we're going to or what properties we need to have for simplified monomials. We know we need to have each base appearing only once, okay? We need to have each base only one time. That's how it's going to be in a simplified form. We also know that there's going to be no power of powers left over, or in other words, you're not going to see any more parentheses. The parentheses are going to be gone. So we want our parentheses to go away. And then all fractions are in simplest form. We need to make sure that we reduce any fraction that we have there. All right, so let's take a look at number 1. I have 4 times x squared times y. Now this is a monomial. There's no addition or subtraction, so I need to combine things that have like bases. Now nothing's happening to the 4. Nothing goes with the y, but I do have this x to the first times x to the second. And when I multiply these two together, I add their powers, so that's going to be x to the third. But that x to the third still is being multiplied by the 4 and still has the y to the third behind it. So now I have no parentheses, x only one time, y only one time, and I'm good. If I look at number 2, now I have these two things in parentheses that are being multiplied. There's no powers on the outside, so that makes life a little easier. Now I just need to put the like parts together. So 3 times 2 gives me 6. And then with the powers, x to the second times x to the fourth, I add their exponents. 2 plus 4 is 6. So that's x to the sixth. A lot of people want to automatically multiply those powers together. You're multiplying the bases. You're not multiplying the powers. When we multiply the bases, we add the powers together. Then the y's, y to the first times y to the eighth, 1 plus 8 is 9. So that's y to the ninth there. Let's take a look at number 3. Ooh, number 3 is good. Number 3, I have 4xyz to the third, all raised to the 0 power. Everything inside here is raised to the 0 power. That means this whole thing drops out and becomes 1. And that's it. Everything goes away. But then in number 4, I have this part that's being raised to the first power, or that's just there, and I have this part that's being raised to the 0 power. So I need to be careful here. Only the stuff that's raised to the 0 power is canceled out to be 1. So that xy to the fourth cancels out to be 1, and then I'm left with 6x to the third y. So 6x to the third y times 1 is still 6x to the third y. Let's flip it over to the back. In number 5, I have 4xy squared to the second power. Now, there's a couple of ways you can think of this. Some people can handle multiplying the powers. I would have 4 squared, which is 16. I would have 1 times 2, which is 2, so that's x squared. And I'd have 2 times 2, which is 4, so that's y squared. Or, I'm sorry, y to the fourth. Hello. There we go. Now, power of powers means multiply the exponents. But if you struggle with these rules, here's one thing you can consider. This power of 2 really means that I'm multiplying this whole thing 2 times. So that's the same as having 4xy squared times 4xy squared. And then it's easy to go back and see 4 times 4 is 16. X to the first times x to the first, 1 plus 1 is 2. Y to the second times y to the second, 2 plus 2 is 4. So I get the same answer. Recognize that this power just means I have the whole thing raised or multiplied 2 times. Okay, so let's talk about that in number 6. In number 6, I have 2xy raised to the fourth. So 2xy raised to the fourth means I really have 2 to the fourth power. And if you plug that into your calculator, 2 to the fourth power is 16. Then I have x to the 1 times 4 power. 1 times 4 is 4. And y to the 1 times 4 power. 1 times 4 is 4. So I end up with 16x to the fourth, y to the fourth. But again, if you struggle with those rules, if remembering those is hard, just consider the fact that this whole thing is being multiplied 4 times. So I have 2xy, 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 and another 2xy. So I took that whole expression, multiplied it by itself 4 times. And then you can go through and see 2 times 2 times 2 times 2 is 16. X to the first, x to the first, x to the first, x to the first, 1, 2, 3, 4. There's 4 of them. Y to the first, y to the first, y to the first, y to the first, 1, 2, 3, 4. There's 4 of them. I get the same answer. It's a little more work to write these out. However, I think people make less mistakes when they do that. So if you want to do it that way, I think that's a good thing, a good idea. So let's talk about just simplifying expressions. So now we're going to start to put some of these rules together. The first one, pretty simple. I have 5x to the 7th times x to the 6th. I don't have anything that goes with the 5. I just need to put my x's together. 7 and 6 is 13. When I'm multiplying, I add the powers. So 5x to the 13th. In number 8, 4ab to the sixth times negative 7a squared b to the third. So I'm going to put my 4 and negative 7 together. 4 times negative 7 is negative 28. And then my a to the first times a squared, 1 plus 2 is 3, so that's a to the third. B to the sixth times b to the third, I have 6 plus 3, which is 9, so that's b to the ninth. So let's take a look at number 9. And number 9, holy cow, lots going on in number 9. So I have this whole thing in the first set of parentheses, 3x y to the fourth. Then I have negative 2y raised to the second, then raised again to the third. Holy buckets. So here's the thing. I'm going to take care of this stuff over here first because I think that will help me. When I have something raised to a power of a power, what's happening, remember that power of power rule, is that I'm multiplying these together. So I have negative 2y raised to the sixth power. And what that means is that I really have 6 of these. Okay, so if it helps you, write them all out. I have negative 2y, negative 2y, negative 2y, negative 2y, and yes, I realize this is long, but it might help you eliminate the mistakes. 1, 2, 3, 4, I need 2 more. Negative 2y, negative 2y. I still have this piece that's out front, 3xy to the fourth. Now I can go back and put them all together. So negative 2 times 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 negative 2. This is going to give me a positive 4. That's going to give me a positive 4. That's going to give me a positive 4. Then 4 times 4 times 4, that's 16. I'm just doing the multiplication here. 16. You can always type this into your calculator, of course. And then 16 times 4 gives me 64. Then I still have to take that times 3, and 3 times 64 is 192. Again, you can go through and type all of this into your calculator. Don't be afraid of that. That's okay. Now go back and look at the variables. So this x is just chilling by itself. That's the only x that I have. But now I got to look at the y's. I have 4 y's right here. I have 1, 2, 3, 4, 5, 6 y's over there. They're all raised to the first power. So that's 1, 2, 3, 4, 5, 6 of them. And then 6 plus 4 gives me 10. So that's y to the 10th power. Oof, there we go. All right, I am going to take care of number 10, which looks equally, if not more, messy. Let me get rid of all of this stuff. Give myself some space. So if I look at number 10, I have a couple of things going on here. I need to raise this whole first power to the third, and then I need this negative 4b to the second. So I'm going to go ahead right away and take care of this because that helps me. 2 times 2 is 4. So I have 1 half a squared b squared raised to the third, and then I have negative 4b raised to the fourth now because I took those powers and multiplied them together. Now I'm going to use my product of powers rule here. You can go through and write this one out 3 times, this one out 4 times, and put them together, but I'm going to use my rules of exponents and show you what that looks like. So I need 1 half to the third power, and I'll go back to my calculator. Oops, 1 half. I'll go back to my calculator to figure out what that is. Then I need a to the second to the third. 2 times 3 gives me 6, so that's a to the sixth. Then I need b to the second to the third. 2 times 3 again is 6, so that's b to the sixth. Then I need negative 4 to the fourth, and again I'm going to go back to my calculator to figure out what that is. B to the fourth, actually b to the first to the fourth, that's just 1 times 4, is b to the fourth. So now let's take care of these. Okay, 1 half raised to the third is 1/8. And if you plug that into your calculator, you'll find that. You'll probably get a decimal, but that's okay. So I have 1/8, a to the sixth, b to the sixth. Then negative 4 to the fourth is positive 256, b to the fourth. So now I can take this 1/8 and this 2/56 and multiply them together. And when I do that, I get 32. I also have b terms that can be put together, b to the 6th and b to the 4th. Now I'm adding those is going to be b to the 10th. So I have a to the 6th, b to the 10th. Okay, those are tricky questions for sure. So be sure you're careful on the practice of getting all of those rules where they need to be. So let's talk about our last two word problems here. I think they're a little bit easier to look at. So express the area of the square as a monomial. So let's just revisit the concept of area of the square. Area of the square is going to be length times width, or in other words, side times side, because in a square, side lengths are the same. So if I take care of that, I have 4ab times 4ab. Now I can combine my like terms here basically. Well, it's not really combining like terms, it's just multiplying the like parts together. So 4 times 4 gives me 16. A to the first times a to the first gives me a to the second. And b to the first times b to the first gives me b to the second. Notice that I'm adding my powers. A times a, 1 plus 1 is 2. B times b, 1 plus 1 is 2. So that's the expression for the area of my square. Technically, this would be units squared, whatever those units may be. We weren't told, but that's fine. If I look at number 12, now I'm expressing the area of the triangle as a monomial. So let's revisit our area of a triangle. Area of a triangle looks like base times height divided by 2. So if I write that out, here's my base, here's my height. I'm going to have 3a to the 4th b times 4ab to the 5th, all divided by 2. Now, in a fraction, you have to simplify the top separate from the bottom and then put those together. So I'm going to go through and simplify the top first. So when I simplify the top, 3 times 4 is 12. A to the 4th times a to the 1st is a to the 5th. And then b to the 1st times b to the 5th is b to the 6th. And that's all being divided by 2. When I combine that with the denominator, I have 12 divided by 2, and that gives me 6. So 6, a to the 5th, b to the 6th. Notice, by the way, that I did not divide my exponents by 2. These are powers, and that's just a coefficient out front. Those are not things in the same place, so they don't get combined. Okay, that's a common misconception. So this is my final area. It would technically be units squared if I were going to label it. And there we are. All right, so that takes us to the end of our notes sheet for Unit 3, Notes 3. And don't forget to check off your notes sheet with Ms. Johnson and come get your practice sheet. And then you can start working like this little guy right here. Have a good day, and thanks for listening.